Hi guys, today I'm back here again with Ted from the YouTube channel called Singster. Hi Ted.
Hi, Eliona.
Don't matter, girl.
We just went over a very interesting paper, Curiosity Algorithm for Robots based on the free energy principle. The paper proposes a curiosity algorithm for robots that leverages the brain theory called the free energy principle. This algorithm is called soft Actor-Critic, and it is a new reinforcement learning algorithm based on the free energy principle. A lot of words. So I wanted to ask you, Ted, could you give overview for our viewers who might not necessarily be technical?
Yeah, sure. Karl Friston's free energy principle. Karl Friston is a neuroscientist from the UK who describes biological thinking, biological thought processes using Bayesian statistics. So it's like biological agents have probability distributions representing the universe from their point of view. So there are some things they're certain about, there are some things they're uncertain about, and so with curiosity, they might explore to find things that they didn't realize.
So do I understand it correctly that the free energy principle states that living creatures learn and infer by minimizing free energy, meaning they measure the prediction error from the sensory inputs like feeling, smell, touch, and then they act in a way to minimize surprise in the future.
In the future is a good way to put it, yeah. So they're trying to make accurate predictions and do so using a really good, robust worldview. But the way they make that robust worldview is by finding things which they can't predict, which change their worldview.
So there is incredibly sophisticated algorithms that tries to mimic human behavior, to where robots strive to balance stability with curiosity.
Yeah, I think that's about right. Where there's the transitioner or the forward model or the world model, which represents a conceptualization of reality, like an idea of the universe, and it's trying to be accurate and it's trying to be stable and robust. But then the actor gets rewarded by the critic if it finds things that the transitioner can't handle. I like to call it an adversarial relationship.
I wanted to start with one of the main topics of my channel, which is the scientific exploration of consciousness. So I prepared some questions for you regarding that paper.
Yeah, please.
It looks like now we are entering the world where we begin to engineer intelligence, but it is still unclear what is the connection between intelligence and consciousness. It seems like we can engineer the properties of intelligence, things like memory, learning, problem solving, planning, and even now that you demonstrate us curiosity. In your opinion, how likely it is that through these advancements we can eventually blur the line between efficient learning algorithms and the emergence of inner experience, self, or even rudimentary consciousness?
I think that's a really interesting question and one which I'm not sure if science can ever solve. I think it's really a more philosophical question. I think in Greece or Rome or some country like that, they have the word qualia, which I think you've talked about on your channel before, where we don't just have eyes which sense things, we're somehow aware of the sensing. And so when we have robots do things, it's really easy for us to like see the code. We can literally look inside the robot's brain, but we don't know if there's any qualia there.
There's also a question, what is the difference between consciousness and intelligence? The robot clearly displays some level of intelligence, but can it blur aligned with consciousness. These Bayesian neural network that you mentioned in your presentation, so I made some notes that a good model for our representation of reality, which is a probabilistic distribution. The one specifically that we discussed captures uncertainty, and uncertainty is a crucial aspect of intelligent behavior. So do you see, and that's somewhat of an exercise in imagination, do you see the future where robots might develop richer internal models, potentially leading to the emergence of higher level of intelligence than human being? And if so, how do you think that future would unfold?
As usual, I think you're asking really interesting and important questions. You mentioned uncertainty in Bayesian neural networks, and that's exactly right, where a Bayesian neural network isn't deterministic. Instead, it's based on probability distributions, which means it can represent what we're certain about and what we're uncertain about. And the free energy principle, part of it is we're trying to minimize uncertainty. We want to maximize our certainty. We want our idea of the reality to be something stable. What you brought up reminds me of a study in biology where there are some insects which don't really seem to have a configurable worldview. There's like a wasp, and the wasp is making a little hole to put an egg in, and it has like a couple steps along the way, and the steps look like they're just about the same for every wasp that does this. So in this experiment, they let the wasp move its egg, and then it started digging the hole, but then they moved the egg. They moved the egg somewhere else. And so the wasp just went over there and it moved the egg, and then it started digging a hole, and then they moved the egg somewhere else. And they could do this any number of times. And the wasp would never sort of catch on. Something's going on here. Which I guess means that like it's really certain about things. It doesn't have a worldview which is able to understand what's going on around it. And another one, which I think is, I think I like this one better. It's kind of cruel. It's sort of a meany thing to do. But they looked at ants, and ants were like walking from one place to another, like from their nest to like somewhere else, and then they would walk back to the nest. And so the scientists let some ants walk to wherever they were going. And then they picked up the ants and they clipped off little parts of their legs. Or they picked up the ants and added stilts. Like they made their legs slightly longer. And when the ants were like set loose so they could wander back to where they came from, the ones with stumped legs didn't go far enough. And the ones which had stilts, they went too far. So their world had changed, and they didn't really consider that. So I guess the point is that some animals don't really do that. Some animals don't notice changes in the way that humans do. Or I'm pretty sure there's some humans that don't even notice changes, or recognizes that don't recognize change in culture or in society. In the paper that I showed you, the free energy is based on accuracy and complexity, which means how much the model is changing. Which means that I guess with those ants and that wasp, they really valued minimizing complexity enough that they were willing to sacrifice accuracy, which means that when things changed, they kept their worldview. They kept their worldview and wouldn't let it change at all.
So are by its very nature, often transcend cultural boundaries, resonating with diverse human emotions and experience. And that's something that you pointed out as a possible function of evolution. Can AI artists, guided by the free energy principle and trained solely on this specific data set, truly break free from its inherent bias that is based on that data set and create art that speaks to universal human condition in the way transcending the limitation of their training data? Or are we fundamentally limited in designing AI art that just mimics to mimicry, replicating and recombining existing artist styles?
I think a lot of the stuff that we have today, I mean, I'm really impressed with the fact that AI can make pictures and really believable text. But you're right that it's all based on things that were fed to it. It's using a lot of human-generated art. It's using a lot of human-generated text, which on one hand, it means that it's always going to be mimicking us if we use that. But on the other hand, to a certain extent, humans, the way that humans learn to make art is by looking at other humans' art. And the way that humans make better and better text is by reading other people's text. But at the same time, I think the way that we have our own individual art styles and our own individual writing styles is not based on just mimicking someone else. Sometimes we want to make a message. We have something somewhere inside us that we didn't really get from someone else, and we want to put it on paper so that we can share it with everyone else. So maybe that's something the free energy principle can do. If we're talking about spreading information by communicating in interesting ways. There's a story, an artist, and in their country there was a great war going on, and he really disapproved of the war. So he made a very abstract looking painting that you've probably seen before, where there's like a screaming woman holding a dead body and like a horse that's going around, and it's like a really abstract vision of war. And he was like confronted, like people from the government confronted him about this, and they pointed at the painting and said, "Did you do this?" And he said, "No, you did this." And I love that. That's such a great romantic vision there, where the artist had something inside him, which was his own reaction to something real, and then he made something which spread information in ways that other people might not have been able to share like that. I imagine maybe if we have the free energy principle somehow making art like in a generative adversarial network or something, maybe it maybe it uses a lot of randomness to make something, and maybe we like the random thing it made. Like you said, a lot of things that we do are remixes, where we have a lot of experience and culture, and we make something new out of what we've experienced in the past. But also, somehow, humans make things which at least seem completely new, where there are new realms of art, new branches of art, and where do those come from? It's weird.
Thank you, Ted.
Do you think the free energy principle could answer a lot of the questions that you asked? Because I think now that I've given those answers, I'm more sure of the free energy principle than I was before. I think there's a lot of questions it can answer.
I think it's an incredibly sophisticated algorithm, but I'm still not convinced that it can model or mimic human behavior and the consciousness behavior, the consciousness that we observe in beings, not even human beings, fully. Guys, check out Singster YouTube channel, Ted a PhD student at Okinawa University in that you made.
It's a Okinawa Institute of Science and Technology.
Thank you so much for sticking until the end, and check out our next video.
Yeah, perfect.